It's chapter 12, Matrices. Today we're going to talk about section 12.2. We're part 1 of 3. And in part 1 of 3 we're going to talk about solving a system of equations with a matrix. So the first thing we're going to have to do is represent the system as a matrix. So let's look at an example system. Let's say we have a system of equations with 3 variables x, y, and z, and our first equation is 3y minus z equals 1. And the second equation is x plus 2y plus 4z equals negative 7. And the third equation is negative 5x minus y minus 6z equals 10. So there's our equation. You guys got that down? Oh, that looks good. All right. So now what we want to do is change this system into a matrix. And how we do that is we take only the coefficients of the variables and the constant. So I'm going to make a matrix that has 3 rows and 4 columns. And each equation is going to be represented by a row, and we're going to only take the coefficients. Now in the first equation, the first coefficient of x is actually 0. So we're going to have a 0, and then the 3, and then the negative 1, and then the constant is 1. The coefficient here on x is 1, the coefficient on y is 2, and then 4, and the constant is negative 7. And then our last row is the negative 5, negative 1, negative 6 with a 10, and there's our matrix. Sometimes the matrix will be represented with like large parentheses instead of these square brackets, and that's just your choice. Sometimes also when they represent a system, they'll put in these dotted lines to separate the variable coefficients from the constants, but that's not necessary either. All right, this is called the augmented matrix for the system. And that's how we do it. Now, once we have the augmented matrix, it's going to be really easy to solve the system of equations, and we're going to see that in the next video in part 2. What we're going to do is take this matrix and get it in what's called reduced row echelon form, and from there we can solve it really easily, and that again will be the next video. So let's really quickly just take a look at a word problem. I love word problems. So here's the word problem, which is about Samantha. Maybe this is Samantha. Here she is. I'm not sure what she's holding in her hand. A snow cone, we'll say. So Samantha has $25,000. Samantha, not Samantha. Samantha invests $25,000 in 3 different mutual funds. Just to diversify her money, and we'll call them, for simplicity, A, B, and C. We know that she puts 4 times as much in A as in B. And then we have some rates of increase. A increases by 10%, B increases by 18%, and C increases by 15%, and over some period of time, and her total is now $28,070. And how much did she invest in each? Because that's what she doesn't know apparently. She doesn't know how much she put in each one, but she knows she started with 25,000. She knows this is what she has now. She knows this is how much they increased, and she happened to remember she put 4 times as much in A and B, but she didn't write down how much she put in each one for some ridiculous reason. All right, let's write our system of equations for this. So first of all, let's call X will be the amount of money she put in A, Y will be the amount of money in B, and Z will be the amount of money she put in Fund C. So X is amount in A, Y is amount in B, and Z is amount in Fund C. All right, so we know when we started out that if we add up all these amounts, they should equal how much she invested, which is 25,000. We also know that she put 4 times as much in A as she did in B, so we know that X is 4 times Y. We want that kind of in this form, so we know that this is the same as X minus 4Y equals 0, so that will be our second equation. And we know when we're done, it's increased by 10% for X, so 1.10 times X. B is increased by 18%, so 1.18 times Y. And our last one is C has increased by 15%, so 1.15 times Z, and that's going to equal the 28,070. So there's our system. Let's put it as an augmented matrix. So we're going to have 1, 1, 1, 25,000, 1, negative 4, 0, 0, and 1.1, 1.18, 1.15, 28,070. And there is our augmented matrix. And now we're ready to go on to part 2 to figure out how to actually use the matrix to solve the problem.